Hello, I am Rishikesh. Today I introduce to software engineering. Software engineering is the discipline that applies engineering principle to the design, development, maintenance, testing, and evolution of software systems. It focuses on producing high quality, reliable, and scalable software through systematic, well defined processes. Reli- Relevance of software engineering in modern development, complexity of modern system, rapid technological advancement, agile development, security and privacy, efficiency and optimization, collaboration and teamwork, customer centric focus. NADA Software Engineering Conference of 1968 and 1969. One of the most important outcome of the 1968 conference was the formal introduction of the term software engineering. Prior of this, software development was often viewed as the informal ad hoc activity. The conference had framed software engineering as the discipline that required a structured systematic approaches similar to traditional engineering field like a civil and mechanical engineering. Software engineering versus software programming. Software engineering is the systematic, disciplinary, and quantifiable approach to the design, development, operation, and maintenance of software systems. It involves applying engineering principle, methodology, and best practice to the entire software development life cycle to ensure that the software is reliable, scalable, maintainable, and meet user requirements. Software programming, also referred to the as coding or development, is the process of writing the actual source code of software application using programming languages. It is a primary focus on the technical task of translating logic and algorithm into the functioning. Programming is just one part of the broader process of software development. Team dynamics. Team dynamics refer to how team members interact, communicate, and collaborate to achieve a common goal in software development project. Effective team dynamics are essential for successful process completion, especially in large, complex software engineering endeavors. Complexity handling. As a software system grow in size and functionality, they become increasingly complex. Handling this complexity is a major challenge in software engineering. Complexity handling refer to the techniques and strategies used to manage, reduce, and navigate to inherent complexity in software system. Long-term software life cycle. The software life cycle refer to the stages a software product goes through from initial conception to retirement. Long-term software life cycle management is about ensuring that the software remains useful, maintainable, and adaptable throughout its entire life cycle. Software process and development. Waterfall. The model is a traditional layered approach to software development that follow a sequential and structured process. In this model, each phase of the software development lifecycle must be completed before moving to the next. The term waterfall reflects the flow of the process where each phase cascades into the next like a waterfall with no turning back once a phase is completed. Agile. Agile is a flexible interactive approach to the software development and the project management that emphasize the collaboration, adaptability, and customer centric delivery. Unlike traditional methods like the waterfall model, which follow a layer and schedule process, Agile encourage continuous improvement and the ability to adapt the changes throughout the development cycle. Develops is a set of practice principle and tools that aim to improve the collaboration and communication between software development and IT operation teams. The goal of DevOps is to shorten the software development lifecycle, increases the frequency of software releases, and improve the quality and reliability of the software being developed. Models, rules, design practice. Models. A software process model represents a structured approach for software development. It defines the phases, activity, and the flow of the task during the software development lifecycle. There are several models, each offering this distinct method for take, tackling, tackling software development. Rules. The rules of software engineering govern the practices and behavior necessary for successful software development. These rules ensure quality, consistency, and efficiency development practices. Design. The design phase of software engineering focus on the creativity and architecture and structure that meets both functional and non-functional requirement. Good design practices ensure that the is a scalable, maintainable, and efficiency. Software cost and maintenance. Software development cost. The cost of software development and maintenance can be a quite sustainability, and it's essential to understand how these costs are distributed throughout the different stage of the software life cycle, from initial planning and designing to development, testing, development, and ongoing maintenance. Each phase incur different cost that can impact the overall budget. Requirement gathering and analysis, system and software design, development and coding, testing and quality assurance development. Software maintenance cost. Once software has been developed and deployed, maintenance become an ongoing cost. Software maintenance refer to the activities required to keep the software functional, reliable, and up to date over time. This include bug fixes, updates, and adaptation to new environment or changing user needs. Corre- Correctivity maintenance, adaptivity maintenance, perfective maintenance, and preventive maintenance. Challenges of complexity, changeability, conformity. Complexity. Complexity refer to the intricacies and interpretations of various components in the software system. As the system grow in functionality and scale, they often become more difficult to design, implement, and maintain. Changeability. Changeability refer to a system's ability to adapt to new requirements, features, and changes in the operation environment. In the world of software change is constant, whether it's updating business requirements, fixing bugs, upgrading technology task, or adapting to user feedback. Conformity involve ensuring that software ad- adheres to established and standard guidelines, regulation, and best practice. This can include everything from code quality standard to legal complements and endorsements to industry, especially regulation. Discuss ethical dilemmas in the field and their potential impacts. Privacy and data security dilemma. One of the most prominent ethical dilemma in software engineering related to the handling of user data. Developer may be tasked with collecting, storing, and using a large amount of personal data, raising questions about how to balance user privacy with the need for functionality. The dilemma arises when software companies collect more data than necessary or use data in a way that users have not ex- explicitly consented to. Potential impact. User trust erosion. User may lose trust in the software if they feel their data is being mishandled or misused. This could lead to a loss of customers and brand reputation damage. Legal consequence. Mishandling personal data can lead to legal consequences such as fines or lawsuits. In some cases, companies might be in violation or regulations like the General Data Protection Regulation of the California Consumer Privacy Act, like a CCPA. Security risk. Poorly secured data can result in data breaches which could expose sensitive information like credit card number, addresses, and personal health data. Algorithmic bias and fairness dilemma. Many software systems, especially those powered by artificial intelligence and machine learning, involve algorithms that make decision that can affect people's lives. However, if these algorithms are trained on basis data or they are not designed to account for fairness, they may un, unintentionally reinforce societal inequalities. Potential impact. Discrimination. Beside algorithm can lead to unfair treatment of individuals or groups, per, perpetrating systematic discrimination such as racial, gender, or socio-ecological disciplinarities. Reputation damage. Organizations that deployed beside system rise public backlash, loss or credibility, and legal action. Software software pens and intellectual properties dilemma. Intellectual properties issues in software engineering often involve the patenting of algorithm, software design, and other digital inventions. The dilemma lies in balancing the protection of creation's right with the fostering involving innovation and collaboration in the software development communities. Potential impact: stifling innovation. Overly broad or aggressive user use of software patents can stifle innovation by preventing developer from building upon technology, existing technologies. Legal challenges: companies may find themselves engaged in legendary potential disputes, which can be costly and time consuming, can divert resources away from development and innovation. Environment impact of software dilemma: software development, especially with the increasing use of cloud computing, big data, and artificial intelligence, can contribute to significant energy consumption and carbon emissions. The dilemma arises when software engineering or companies' priorities perform scalability and convention over environment sustainability. Potential impact: environmental damage. The energy consumptions associated with the software development, practic- particularly in data centers and blockchain mining operations, can contribute to climate change. Climate change. Public scrutiny. Companies that fail to adopt a green technology and environmentally responsible practices may face public criticism and consumer backlash. Regulatory pressure. Government may impose regulation or taxes on high energy consumption industries, including tech companies, to meet environmental damage. ACM Code of Ethics. Public interest software professionals should prioritize the public good and ensure that their work contribute to the well-being of individuals and society as a whole. This include ensure that technology respect the rights and freedom of all people. Professional competence. Professionals should maintain their knowledge and skills, keep up with new technologies, and provide high quality work. This involves ensure that the software development meets appropriate standards and it's free for harmful errors. Honesty and integrity. Software engineers must be honest and transparent about the work, including acknowledging the limitation and risk of their products. They should not deceive clients or user and must take responsibility for their decisions. Respect for privacy. The protection of user privacy is a paramount. Software professionals should respect the privacy of all individuals, ensuring that their system collection, store, and process data responsibly and securely. IEEE Code of Ethics. Public welfare. IEEE members are expected to hold the safety, health, and welfare of the public as their primary concern. This principle ensures that engineers create a system that are safe, reliable, and beneficial to society. Honesty and integrity. Similar to ACM code, the IEEE code of emphasizes and importance of honesty in all professional activities. Engineers must be truthful in all aspects of their work, including reporting results, making claims, and dealing with clients. Fairness and justice. Engineers should strive for the fairness and justice in their professional interaction. This involves treating all colleagues, clients, and stakeholders with equal and ensure that their action do not cause discrimination or harm. Thank you.